the last video, we spoke about front running. And in this video, we're going to talk about how to destroy front running and get your arbitrage or your swap transaction across undetected, privately and hidden, either on the Ethereum blockchain, the Binance Smart Chain, Arbitrum, Polygon, whatever, using Submarine Send. Now, this could be extremely useful if you're into sniping and you want a transaction to go through without having to think about slippage issues, etc., without having to think about front runners trying to outdo you. And this could also be of interest to you if you're interested in doing arbitrage transactions and also having front runners have no idea about your transaction going through. Now, at the end of this video, I am going to play devil's advocate because the blockchain is not private. Nothing is private on the blockchain. But I think you'll find that this approach is very unique, very interesting, and it makes it extremely difficult for front runners to go and front run you. Now, if we go back to the last video, we'll remember we had our friend here, bot Fred, although he wasn't our friend because he was basically scanning the transaction pool, the mempool, looking for transactions like mine where I wasn't paying much gas and where I had high slippage, etc. And he was getting his bot to jump ahead of me by paying more gas and then basically sandwiching me and selling me my tokens back at a higher price based on the slippage that I had put in. Now, I still want to get my coin. Maybe here, for example, I want to get into Ape token. I know that the launch has been coming up, etc., and I want to get into that. And yes, I know this is way back now in the past, but let's say I want to get some of this token and I don't want to be hit by front runners. The problem is that these bots are looking at every transaction that comes through and they are looking at the data in that transaction. Now, I showed you in the last video how to actually do this for real on the Ethereum blockchain and monitor transactions. That said, it's very, very easy when they know that you're looking, for example, to do a swap on Uniswap. They know exactly what they're looking for. This is built into their bot, so this is very easy for them. So the name of the game here is how do we get our transaction to look like every other transaction and look irrelevant to the bot, hiding in plain sight? Well, we can actually go and do that if we give it some thought. And this is a special thanks to the folk at libsubmarine.org. So Submarine Send is something that I learned a lot about from their documentation. I looked at some of their Python code, etc. I've been able to get some of that into Ethers.js, and I've been able to work out how to do a variant of, let's call it a Submarine Send, thanks to the documentation they put out online. So essentially the way that you can hide transactions is through something known as a commit and reveal scheme. And this is exactly how it sounds. The first thing you do is you commit a transaction, and that would be in stage 1. And then you would send a separate transaction in stage 2 to reveal the transaction that you initially committed to. Now, I want to talk in terms of the context of doing swaps or arbitrage because that's what we care about here at this channel. But to help you understand the true nature of commit and reveal, I'm going to simplify it first, and then I'm going to complicate it a bit more so that it works for us and our needs here at Crypto Wizards. So remember, our friend is scanning every transaction here. So I don't want to send a commit transaction or a reveal transaction that can allude to the kind of swap I'm looking to do, etc. I don't want to give them a sniff of what I'm doing. And the problem is that my transaction includes all of that information. So I need to try to hide that transaction. And the way I'm going to do it is through this commit and reveal. So step 1, I'm going to send some kind of value to an account. And then in step 2, I'm going to go and execute the swap after the fact. Now, this wouldn't work for a swap as I've just shown you here right now, but at least you get the idea of the nature here. We're doing 2 transactions. One is to commit a value to an address or a smart contract. And then the second transaction is to go and say, okay, cool, I've committed that value. Here's proof I've committed that value. Now go and execute it. You could do that for a swap, for arbitrage, for a vote, for whatever it's going to be. And you would do that using a password. Now, please don't try to understand this in detail yet because I've not given you enough information. This is just so that you understand the nature that there's a commit phase where we send the actual Ethereum to a contract or an address, and that then there's a reveal stage where the smart contract will then work out, okay, is this person who they say they are, etc. Now, let's try to simplify this a bit more because I want you to understand the nature of the submarine send. So what does this whole submarine send thing mean? Well, let's talk about a voting example. Let's say I want to cast a vote, but I only want to reveal after a certain block number what the vote was. Well, one of the ways I can do that is I can construct an Ethereum account that has no private key. And yes, there's a lot of objections to doing that, but let's just do that for now. Let's construct an Ethereum account with no private key, and you can do that. You set up this hash function basically that spits out an Ethereum account, and that is constructed based on a password you decide, maybe your account address or whatever you want to feed into that, and you hash that a certain way, and you get out this Ethereum account. So you're just using transaction data that includes a password that only you know. So it really is a useless account. It's a fresh account, it's brand new. No one's seen that account before. It's just an address, and it has no private key at this point. So what we're then going to do is go and commit 3 Ethereum to that account. In this example, 3 ETH. It could be any number, but that is our commit done. We actually just go and send 3 Ethereum. Now you can imagine our bot Fred has only just seen a transfer. They've not seen any data to do with a Uniswap swap, nothing like that at all in the example of doing a swap. But in the example of voting, no one's seen us cast a vote. But we have now transferred value, and we can prove we've transferred value to an Ethereum account. And then in the next step, we will reveal the transaction. So we will actually go and call a smart contract. It could be the voting smart contract, for example, to say, hey, look here, funds were sent to an account that we can prove has no private key, because look, you can check yourself how this was actually created, how this account was created. Therefore, it can have no private key. And so this contract goes, okay, let me go and check, and comes back and says, yep, okay, transaction accepted. I can see that it was real. I can see you actually did also commit value to that contract. And therefore, this vote that you've just sent me with data on now after the fact, where a front runner couldn't have seen what I was voting for, etc. Now it's irrelevant because it's happened after the block number, etc. So that's what this reveal contract could do. But the idea here of the submarine send is to create an account with a unique address that matches the type of transaction data that we're sending, or a password we're sending, etc. That can be checked at the reveal stage. And this is really the key here. Now, if you don't understand yet, I don't blame you. This honestly took me weeks to get my head around, and I'm about to complicate it even more, but you might find in me doing that, it'll start to make sense to you. Because right now, the problem by doing this is that we're very sad because we just sent 3 Ethereum to an account where no one can get that Ethereum back, right? It's been sent to an account address with no private key. I've lost that Ethereum. That is not going to work for us. Not at Crypto Wizards. We want to do a swap. I want to do arbitrage. I don't want to lose my funds, and I certainly don't want to lose them to a front runner as well. So right now we're pretty sad, but then we come up with an idea. This is something I've been working on through the reading on Submarine Sends. I've constructed it. I'm going to actually walk you through one on the Gurley testnet live on Ethereum, but here's how we would do it. So the first thing we would do is create what's called a factory contract. And this is just a one-off creation. We can use this and reuse this for yonks into the future if we want to. But a factory contract is very useful because what it does is it creates other smart contracts. And just like we created our Ethereum address before, there's also a way with Solidity using something called create2 to create a smart contract address that you can then go and withdraw funds from, etc. So we can actually create this submarine contract by calling this factory contract. And it knows it's us because we're the sender to the contract, so it can store all sorts of information against our address that only we can access because the functions that we put into this contract are private. Now, one thing to notice as well is that this is the blockchain. So if you do store that sort of information in the contract, or you choose to, you don't have to, then some miner or somebody who's running Geth or some Ethereum clients, if they were really smart and caught on to what you were doing, they could work it out. But then again, you could change the game again. So this is very much a cat and mouse game, which is the nature of front running. That said, we have a function in here that creates smart contracts. And when we call it, it will go and create our submarine contract. Now that smart contract is only empty in terms of value. It's not empty in terms of functions. It's got some information embedded into it. So it has information about who the sender was, who the owner is, i.e. you, and it has a function that performs a swap to any token it's sent. And so once it receives the information about that token, it can go and get the latest, most up-to-date price for that swap on that token, and at the same time, as soon as doing that, in the same transaction, execute the swap. So it's not even thinking about slippage, etc. It's just going to execute that swap. It's going to get the price and execute all in one go. And here's the super cool thing. It's then going to self-destruct. So after it performs that swap, it's going to self-destruct. And when you self-destruct a smart contract, which is a deprecated function, unfortunately, but it does still work, you will get some gas back. So it won't charge you 100% of the gas. This is an idea that I thought was pretty cool. I've tested it out and it actually works. But let's just take a step back, right? So right now, we had our factory contract and we've created a submarine contract, which right now has done nothing. It's got 0 Ethereum in it. And so in the next step, what we do is we send our 3 Ethereum to that submarine smart contract. And that means it now has 3 ETH in it. And then once we've done that commit, because that's our committed phase, we then go ahead and we say, okay, now that we've gone and committed funds to the submarine smart contract, I am ready to now go and execute my swap. But think about this from Botfred's perspective, because Botfred right now has only seen a transfer to a new address. This address has had no history to it before. It's a brand new address. You know the address because you calculated it and you predetermined the address in a very special way, but you know what the address is. They don't. And so this looks like any other transfer of 3 Ethereum. And then in the reveal transaction, you have your reveal smart contract. Now this is very clever because it stored information from your factory contract. Your factory contract at the same time as creating your submarine contract went to your reveal contract and also stored some information about you. But what it didn't store was what's known as your salt. Think of your salt as your password, right? It stored the factory information, it stored some bytecode information, but it did not store your password. Only you know that. And so this can only be called when the password is sent to the reveal contract. And when it is, the reveal contract will call the perform swap function in the submarine contract. And when it calls that, it will perform the swap on the token that you sent to the reveal contract. So it'll forward that whatever token you want to trade over. You could even have it so the submarine contract is predetermined to know what token you want to trade. But I thought it would be safer to do it this way to, if the front runners were coming onto you or they were working out what you were doing, the more you can try to trick them, the better, basically. And so what we're doing here is calling that swap. When that swap executes successfully, it will then destroy the submarine contract itself, and that will save you some gas, and any Ethereum left in that submarine contract will also be paid back to you. So not only will you get any remaining ETH paid to you, because it will try to swap all 3 Ethereum, and it'll do that by converting it to wrapped Ethereum and then to your token that you want to buy. And it will try to do that. If there's any remaining amount, it'll still send you that ETH. Plus, when you update your MetaMask for the token you try to swap for, you will also see the balance of that token you swapped for. So this could be really, really useful for sniping. And that basically looks like something like this. You can see it here. I'm actually going to do one with you now, but you can see it over here right now. Here's the transaction. Here's what it looks like. Here's a contract address. This was done live on the Gurley test network on Ethereum. And you can see here, I swapped it for 29 USDC, and you can see it there in my MetaMask wallet as well. You can see the transactions that went through here in the submarine contract. But now what about the gas? What did this actually cost me? Because there's a lot going on here. Well, let's look at that. I'm going to ignore what it cost to make the factory and the reveal contracts, because those should be one-off sunk costs. But to make the submarine contract, was 781,000 gas that was used. The Ethereum transaction to send Ethereum was about 21,000 gas, and to execute the reveal side was 179,000. So in total, we've used up about 981,000 gas. And when you look at that at the latest prices on the Ethereum blockchain, that's about $36 US. On Arbitrum, it's $1.50, on Binance Smart Chain, $1.80, etc. So in my opinion, it's actually very cost efficient, and you could definitely make the code more efficient. I know there's those of you that I chat with who are super into your coding, and you have some very good ways and novel ways of getting around gas. here. Now, I've custom built one, tailored it for swaps in particular. You could tailor one for arbitrage, and I do think everything should be tailored based on the use case that you're doing. So let's go now and actually have a look at this running on the Goerli testnet right now. All right, so I'm over here at Hardhat right now, and I'm going to go and run these steps for you. I'm actually going to run them in 7 steps. I've broken it down more so that you get more of an understanding of what's going on. Now, just note, you can go and grab this code. I've put a link in the description as well. And if you are a member of Crypto Wizards, you have access to this all for free, by the way. This is so that you don't have to go to Udemy, wait for a whole Udemy course. If you do want a Udemy course where I build this for you line by line and explain everything, put that in the comments. If enough people want it, I will put in the time. It is very time consuming. It does take a long time to make those courses, but if it's useful for people and they'll learn a lot, I'm happy to do it. But for now, just note that I've built a coding arm for Crypto Wizards. It's called coderaiders.com. So you can come here and get that code. Just make sure that you use the same email address where you're a member of Crypto Wizards, so that it knows you and it won't try to charge you for the code, right? So that's something that's very important. But now if you scroll down, you'll see that there is a place here where you can grab the code, and there's also a video walkthrough. So it actually walks through what I'm about to do for you step by step, how to install it, how to do everything basically. And I go through it in the video in great detail so that you can actually see how all these steps are working. But right now I'm going to race through it because I don't want this video to be too long. Now, the first thing I want to do is actually go and deploy my reveal smart contract and my factory smart contract. So what I'm going to do here is I'm actually just going to go and run this command, which will run step 1. So step 1 is actually to create the factory and reveal contracts. And let's go and do that now. Great, we have our reveal address created. So I'm going to copy that and I'm going to paste it here into my environment variables right now. If you're not a coder, don't worry about that. For the time being, I'm just storing what is the actual contract address for the reveal contract so that the code can use it later. And now it's working on the factory contract, and there it is, it's done. There's the factory contract address as well. So I've got those 2 contract addresses. Now, if I go over here to Etherscan and I just grab my MetaMask account over here for now and paste that in, let's actually have a look. Here you can see I've got this contract created over here, right? Contract creation 43 seconds ago. And actually, if I refresh that, there's the other one as well, 27 seconds ago. I can actually go and see that that's successful there on the Goerli testnet network. Great. So there they are, and they're stored here. And I've also got the token swap address too, which is great. Now, the token swap address and this unique integer are going to be what's known as our salt. They are going to be what is used to generate our password. And that's done through all sorts of complex code to generate the salt. It's all in here, but that's essentially what it's used for. So every time I create a new submarine address, I should increment this by 1, because if I try and create it with the same salt information, it'll create the same address. And if one already exists, it will fail. So let's just keep it as is for now. We'll keep that as 0, and that is as it is. And let's go here and do step 2, which is to go and create the submarine contract. So what that's going to do is that's having this factory over here go and create this submarine contract. That's what step 2 is doing right now. Fantastic. And it's given us some information. Here's a transaction reference, over here. This is the salt that was used. So it's telling me what that was. Here's the, predicted address, I should say. And here's the transaction hash here. So this is the predicted address. If I change this to 1, the address would be different. If I change it back to 0, it would be the same. And that is very important, because if we try to create an address that's already been created, it'll fail. Let's go and have a look at the transaction. Very important that that goes through before we go and send Ethereum to it. So let's go and have a look here. And successful. Yes, we have a submarine smart contract with 0 Ether in it right now. So what I'm going to go and do now is just check that that is all correct. That's what step 3 does. It checks the predicted address against the actual address. And so what I need to do actually is I need to take this predicted address. I'm going to copy it in here, submarine address, and let's go and run that again. And there you go. You can see it saying, yes, your addresses match. So here's the address I saved, and it's saying, great, exact match with a smiley face. So make sure, we save our submarine address here. And again, I'll walk through this over on the Code Raiders page, where I've put a link in the description to that. So I'll talk a bit more about that. But there you go. That part is done. So now we can proceed to step 4 and actually send our Ethereum. So here in step 4, I'm sending 0.001 ETH, and I'm going to go and send that right now. Boom, there you go. Here's our transaction hash. Let's go and check that out. I'm speeding up a bit because there's a whole video covering this stuff and more in more detail. Now that's pending. Let's wait for that to go through. And while we wait, let's just go and show you here. This is what's happening. We've just sent some Ethereum to our smart contract and we've committed our transaction. Now, if I go back here, it's still pending, but I reckon in a second it's going to finish. Yep, there you go. And we now have that transaction that's gone through. So let's just go and make sure we check that. So what I'm going to do here is go to step 5, which is just to check the balance of the Submarine smart contract. And yep, there is now 0.001 ETH in there. But now I want to perform the swap. So what I want to do now that I've committed that, it's gone as a Submarine Send. It's basically to this front runner. If we go back on our presentation, it looks like every one of these other transactions right now. None of this data was sent. Has no idea. Our front runner has no idea about all of this right now, which is all very exciting. But what we're going to now do is go and call our reveal contract. We're going to pass our salt with it, and it knows about the factory and the bytecode because we've stored that in this instance. There's so many ways you could do this, by the way, but I had my factory go and store that already in the reveal contract, so that all I need to do now is send it the salt. It's going to know the submarine address from that salt and then go and call the submarine address to perform the swap. If everything's successful, it'll destroy itself as well, and I'll have some more USDC in my account. So right now I've got, let's have a look here, I've got 70 USDC in my account right now. So let's go and have some fun with this and see what happens. So right now I'm going to go here and do step 6 and reveal the transaction. And there we go, performing the swap, and it's showing me my current balance. It's given me here my transaction reference. So let's go here to Etherscan, and I want to go and see this here, transaction pending. Let's give it another 15 seconds or so to actually go through. And wow, that took about 35 seconds, I would say, in total to go through. But there we are, we've got our transaction, and here you can see it right here, right? So we've gone and swapped for wrapped Ethereum within the smart contract. It checked the price, it executed at whatever best price it found at that moment in time, and it swapped for 40 USDC. So now if I look at my balance, yep, we've gone from, what was it, 70 to now 110 USDC. And we've also destroyed the smart contract. And let me show you that down here. If I scroll down, you can see that we only used 86% of the gas there because we went and self-destructed the submarine contract, therefore saving on some gas. How cool is that? When you do get to the code over here, just read it. We've got the factory live, read through the submarine contract, read through here the factory live contract. There's also a factory test. That's just so that here you can run npx hard hat test, and that just makes sure everything's working. And when you follow the instructions I've laid out for you, it should all work perfectly. And that just goes and runs a lot of ethers.js to check this is all working. But the test contract doesn't have the swap in it, doesn't have the swap code. The live contract does. And of course, here's your reveal contract as well. Now, Wizard, I know I'm actually losing daylight over here right now. And don't worry, I've got my laptop to light me up, and I've got a little bit of sunshine left. But let me just play devil's advocate for a moment here, because I want to be very clear. Yes, you can send private transactions on the Ethereum or whatever EVM-based blockchain, but you can't, because they can never be truly private. Anyone running the blockchain, if they know what they're looking for, they can find the data you put on. So that's why, for example, you should never store a private key in a smart contract, because it can be hacked, it can be found. But that said, if you change and tweak how you store and save data as you keep doing swaps or snipes or whatever it is you're doing, you're making it very difficult for others to keep up with what you're doing. So I would say it's a bit like being in battle maybe. Don't stay in the same place too long. Change your smart contracts up a bit. Where is, the token stored? How is it sent? Where is it sent from? If it's an arbitrage transaction, do you want to have one transaction in one smart contract or one token stored in one smart contract in terms of what you're going to swap, and then it gets called through 3 transactions? It depends, and it depends on the complexity of what you're trying to do. A front runner If they know what you're doing and they have the contract addresses, they can listen out for your transactions. Choose what side you want to be on here. And I really hope that all the research that went into this is going to do very well for you and hopefully put you ahead of the curve and ahead of most when it comes to doing swaps, arbitrage trades, etc. in crypto. Till the next one, take care and talk soon.